Hello and welcome to Mission 3, Lesson 23. It's the Michael Jordan lesson. All right, our student objective for this lesson is to use division and the associative property to test for factors and observe patterns. So, essentially what we're going to do, we're going to use division to determine if one number is a factor of another number. So, we're going to determine if one number is a factor of another number using division. So I'm going to explain that, and we're going to go over a couple examples to figure out. So let's do that right now. Okay, so here is one example. So Inzern's going to ask you, is 2 a factor of 52? So we're trying to figure out, yes or no, is 2 a factor of 52? So when you're given a number and you are asked if it's a factor of another number, what you need to do is divide those numbers. So again, you need to divide. We're going to divide 52 divided by 2. Okay, and so we're going to do that, and then I'll tell you how you can tell if it's a factor or not. So whatever they give us, we can divide. So let us do that. So if we're doing the standard algorithm way, I have 52 divided by 2. Okay, or if you prefer to draw it out, if I had a place value chart. Yeah, let's undo that real quick. If I had a place value chart, so I had tens and ones, I could put 52, 5, 2, and I could then, I'm dividing them into, I know this is sloppy, 2 groups because I'm dividing by 2. So again, I start with my tens. I'm going to start over here with my tens first. A 10 goes there, check it off. A 10 goes here, check it off. Another 10 goes here, check it off. Another 10 goes here, check it off. Now, I still have this very last one remaining, but I can't divide that evenly. So what do? I unbundle it, I move it to the ones, so it becomes 10 more ones. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and now I'm going to do that. I'm just going to distribute these 12 ones I have. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, and then I have 2 left. 1, 2, 2. Okay, so how many did I end up with in each group? Well, I had 2 tens and 1, 2, 3, 4, 5, 6 ones. So that equals 26. Okay, I'm going to do the same thing, just the standard algorithm way. So divide, multiply, subtract, bring down. So I start with the tens place. I do 5 divided by 2. How many times does 2 go into 5 without going over? It goes in 2 times. So then I do multiply. 2 times 2 is 4. I write it right under there. Then I subtract. 5 minus 4 is 1, because I had 1 left over. I bring down the ones, the next place value. So it's 12, which again, just what I had here. I had 12 ones. And now I'm going to divide 12 divided by 2, because I'm starting the process over. 12 divided by 2 is 6. Okay, 2 times 6 is my multiply step, is 12. I subtract them, 0. Nothing left to bring down. So 52 divided by 2 equals 26, as we've seen here. Now, how do we know then if is 2 a factor of 52 is what we're being asked. If you divide the 2 numbers and there is no remainder, then it is a factor of that number. So if you can divide a number evenly into another number without a remainder, then yes, it is a factor. Yes, it is. If there is a remainder, then it's not a factor. So that's your key. If there's no remainder, it's a factor. If there is a remainder, it's not a factor. Because if I had this one, is 3 a factor of 73? Well, I'm just going to do 73 divided by 3. And again, my steps are divide, multiply, subtract, bring down. I do 7 divided by 3. Well, 3 can go into 7 2 times without going over. 3, 6. Okay. And then I multiply. 3 times 2 is 6. Then I subtract. 7 minus 6 is 1. I bring down the 3, so it's 13. And then I start the process over because I just brought it down, so I divide again. So now I go 13 divided by 3. How many times can 3 go into 13 without going over? Let's see. 3, 6, 9, 12. 15 would be too high. So 4 times. Because 3 times 4 is 12. And then I subtract. 13 minus 12 is 1. And then there's nothing left to bring down. So that 1 I have is a remainder. 24 with a remainder of 1. So 73 divided by 3 is 24 with a remainder of 1. So does this have a remainder? Yes, it does. So if there's a remainder, it does not divide in evenly. So therefore, it is not a factor. 3 is not a factor of 73 because there was a remainder. So that's what you're looking for. When you divide, if there is no remainder, then the number is a factor. If there is a remainder, then it is not. So you just need to keep that in mind as you're doing today's lesson and still practicing that division, and now just kind of expanding what we know about factors into that. So remember, remainder, not a factor. No remainder, it is a factor. Okay. Good luck.